Hey Fres, you're late. We're working on a project right now.
Hello, my name is Ahmed, and I will be talking about the car in our project. We built our car from scratch. First, we made a rectangular frame out of metal Vex angle bars.
So, what are you guys working on here?
While you were gone, we were finishing up the frame, putting the motors in currently, and we're testing them out to see how fast they go.
I see. So we've got the whole frame built.
Yeah, we have motors in.
Motors turning. All right. Nice. So we're just tinkering, putting the wheels in right now.
Absolutely.
Good job, guys.
To make the car move, we use 4 Vex motors and 4 rubber wheels which we attach to the frame. We use metal screws and nuts to put everything together. For the movement, we use motor controllers, which allow us to put inputs on the motor using the Arduino Uno microcontroller. We rested the Arduino Uno microcontroller and the breadboard on the metal plate, which we placed on top of our frame. All the wiring on the motor controllers and the Arduino are done on the breadboard.
The servos turn due to the servo library which comes with the Arduino board. They are held in an array of servos and then they are given specific values on how to turn. The Bluetooth, however, also uses inbuilt library, but we had to have them pair up, which is more of a challenge. So what we did for that was we used a wire after we took off the plastic covering on it, and then we sent a 1 to that wire so that it would receive 5 volts, and then it would go into this configuration type mode and we had to manually configure it. This is something which took us a couple of days maybe or something.
All right.
Yeah.
So Hill,
Yes.
what are you working on right now?
I am working on Bluetooth connection. Pretty much what I've done so far is I'm sending values from this flex sensor to my phone via Bluetooth connection. As you can see, those crazy numbers popping up. Right? Look, if I bend it, it shows it right there.
So he's bending it now. The
Value
values change. Might
Yes.
be able to see. Yep, the values change, but
Yeah.
see the same. This is the code running it right now.
It's not advanced at all.
Not very advanced,
Yeah.
but progress all the
Yeah.
same.
Yes.
That's
Good.
good.
So there's 2 essentials files in this project. Pretty much there's one on the glove and there's one on the car. The one on the glove sends a specific letter depending on how much each finger is flexed via Bluetooth to the car. The car, depending on that letter, moves forward, back, left or right, or just stops.
The key feature of our project is being able to control the movement of the car by moving your hand when wearing our custom glove. Our custom glove contains flex sensors, which are the components that are responsible for controlling the motion of the car. The flex sensors are stitched to each finger of the glove, meaning that bending your fingers also bends the flex sensors. We soldered a power and ground wire to each of the 5 flex sensors to allow it to output its signals to the breadboard. If none of your fingers are bent, the car remains stationary. Bending only your index finger makes the car turn left. Bending only your middle finger makes the car move forward. Bending only your ring finger makes the car move backward. Finally, bending only your pinky makes the car turn right. This is possible because the flex sensors board and the car's Arduino board being paired via Bluetooth.
Hey, Faraz here. Making this car was a lot of fun, but there were a few hiccups along the way. My expert soldering interfered with the flex sensors, so I had to redo it multiple times. Mounting the board onto the shin guard was a pain, because the material the shin guard was made of was very strong, so we had to shear it off. Shout out to Michael Chilapa, by the way, he helped us out a lot in the wood shop. Finally, the biggest issue was finding working motor controllers. These things would break on a day-to-day basis, and would always require replacements. Somehow, whenever we were testing the motors, there was always an issue. Either the breadboard was fried, the Arduino wasn't working, the code didn't run correctly. All in all, the motors were easily the biggest obstacle. However, we ended up overcoming all of them to make our finished product.